Neutrophils and their processes. Neutrophils are a type of white blood cell. They make up to 55 to 70% of your white blood cells. The fluid mosaic model describes the structure of the plasma membrane as a mosaic of components. Its flexibility allows for certain activities to occur, such as active transport, which will be further explained throughout the video. Hence its name, fluid mosaic. The fluid mosaic model consists of phospholipids, which make up the phospholipid bilayer. Each phospholipid consists of 2 fatty acid tails, which are hydrophobic, and 1 phosphate head, which is hydrophilic. Cholesterol functions to immobilize the outer surface of the membrane, reducing fluidity. It makes the membrane less permeable to very small water-soluble molecules that would otherwise freely cross. Furthermore, glycoproteins are embedded at the top of the membrane and consist of a carbohydrate chain. Diffusion is a passive movement of molecules from an area of high concentration to an area of low concentration. Passive diffusion is a movement of molecules across the membrane and does not need energy for it to occur. In facilitated diffusion, a molecule is transported across the membrane with the help of a carrier protein. In this case, for neutrophils, a transporter protein called the GLUT1 facilitates the transport of glucose across the plasma membranes of mammalian cells. Osmosis is the process where solvent molecules move through a semi-permeable membrane from a dilute solution into a more concentrated solution. Aquaporin 9, a water/glycerol channel protein, is expressed in several immune cells, including neutrophils. Active transport of a neutrophil. In order for a neutrophil to undergo phagocytosis, a carrier protein called C1q is needed. C1q serves as a bridging molecule for an apoptotic cell clearance by binding to the apoptotic cell in the phagocyte and stimulating engulfment, independent of the classical complement pathway. Tuberculosis is initiated following the inhalation of droplets containing a small number of bacilli. Once in the lung, bacilli are internalized through phagocytosis. That entire process requires physical movement on the part of the predator microbe and will absolutely require energy, mostly in the form of ATP. Examples of exocytosis. Exocytosis, also known as degranulation in neutrophil, is the release preformed mediators from granules. Granule subsets are markedly different in their capacity for mobilization in response to stimulation. This event requires fusion of the subcellular storage organelles within the plasma membrane. Since the neutrophil is phagocyte, 2 pathways of exocytosis must be distinguished. 1. The release into phagocytic vacuoles by fusion of storage organelles with portions of the plasma lemma which committed to form or have already formed phagocytic vacuoles. And 2. Phagocytosis independent release by fusion of storage organelles with areas of the plasma membrane that are not involved in phagocytic uptake. The latter pathway is popularly termed secretion.